Hey, thanks folks for attending. This is episode 4, right? I can't believe we've done 3 of these. There was even one before this. It is rare that I do this many webcasts with a given vendor, but I have to give Endace, our sponsor today, just fantastic street cred or just credit in general. I mean, they get street cred just for who they are, but fantastic credit for making this available to the SANS community. I will start by mentioning here that the data I'm going to cover today is actually available over at Endace DNS. So basically the malware Jake public and Endace DNS. So if you want to play along, feel free because the data is there, right? I do want to, again, give Endace a huge shout out here, and I'm going to cover a little bit about like operationalizing packet capture before we deep dive into the DNS side. Probably worth mentioning as well is that we've done a couple of these up to this point. We did one around HTTP and taking a hard look at doing packet analysis and packet capture analysis with HTTP. Another one, SMB. We did another one looking at email most recently, and now we're on to DNS. All right, so definitely take a look at those other webcasts as well. The data for those is also available. Right, so those are all in the SANS webcast archive. Data for that's available. But before I get going today, again, I would be completely remiss. We will take a look at the Endace probe as well, but I'd be completely remiss not again to talk Endace up a bit here. Beyond the fact that they have a fantastic product, right, with their packet capture probe and the analysis that you can do on board with that. And again, I'll touch on that here in a second before we get into the detailed packet analysis. It never happens that a vendor comes up and says, hey, we want to teach people the underlying technology behind it. This is like the equivalent of an EDR vendor coming to me and being like, Jake, minimally talk about the product, but then educate people on how threats work so they can hunt better. And they'll probably use our EDR too, right? Kind of thing. That just doesn't happen, right? And so the value to the community that's been given here is just phenomenal. When I see a vendor like Endace, really come out and be like, hey, we want to teach people how to do more packet analysis, to do better packet analysis. Let's, to the extent we can deep dive in an hour, let's go cover some packet analysis. It's going to be awesome, right? That's what we're up against. I say what we're up against. That's what they've done for us here. And they've sponsored a number of these sessions. Again, this is actually, I guess, as I'm looking at this is actually our, I believe, 6th webcast together this year. The first one, we actually looked at some Hafnium and Sunburst traffic, right? So you remember Sunburst from Solaragate. I don't know how many times I've done that. Solaragate, aka the SolarWinds fiasco, and then of course Hafnium targeting exchange servers, right? So we had some packet capture there and really covered deep down on what does the probe do, how does that work. I also wrote a white paper, for them. We did a little bit of coverage there. They actually brought an awesome demo and showed how they're now running Zeek on the probe. If you're not familiar with Zeek, that's been renamed from Bro. Used to be Bro, now Zeek. And did some fantastic work there. Really, really impressed with that. And then, as I mentioned before, we did deep dives on HTTP. We did SMB. We did email protocols, primarily SMTP and IMAP. This POP is, I'm gonna say dead, but kind of dead, right? And did some deep dive into headers there. And now we're doing some DNS, right? So again, we've been around the way here with these folks or been around the way with these folks. These folks, Endace, have allowed us to bring this content to the SANS community. And I can't say enough great things about them. If you're ever at a conference with these folks, check them out or just talk to them now, what have you. Mark from Endace is actually on the line with me today and can answer questions as necessary. So the data is public. You can go take a look at that. I do have a readme.txt in there that basically a couple of the samples. Some of them I generated. A few of them were generated by Endace. And then I've got one from a B-Sides Capture the Flag and a couple from the Wireshark sample wiki, right? And we probably won't cover all of these today. I want to highlight a couple things in a couple of different spaces, and then we'll kind of see where the day takes us, right? Or I say the hour takes us. Typically, my problem has been I run out of time, and then I'm like rushing at the end here, so we'll see. All that said, right? Please take advantage of this because again, you can go back, obviously replay the webcast. You can obviously then replay the analysis. Typically this is the kind of stuff that doesn't happen. One other person though that I do want to mention Chris Sanders, as we were getting ready for this webcast, they reached the Endace folks, getting some packet capture samples, reached out to Chris Sanders. I ended up not using any of his stuff, but he did provide stuff for us and just wanted to, right? Chris runs the Rural Tech Fund. He's awesome. And again, just demonstrated that yet again by offering up some packet capture samples. Again, stuff I ultimately ended up not using, but still. Okay, so that said, let's get into this and talk about why packet capture, because there's so much else out there, right? First off, I want to start with what's at the bottom of the screen here, and that's that I go to security conferences regularly, a lot more pre-COVID, right? But I've still been to a couple in person, even. Hopefully the whole new strain thing doesn't kill a bunch of in-person conferences again. But look, when I walk around conferences, it's every conference I see somebody with a t-shirt that says PCAP or didn't happen, right? And I never run into somebody that has a shirt that's like endpoint logs or it didn't happen, right? Never happens. Doesn't ever occur. I've never seen that t-shirt. I don't think anybody ever made it. And there's a reason for that, right? Packet capture is ground truth. It's out of band, right? Typically when we capture packets, we're capturing those out of band. This makes it a phenomenal place for us to go and grab data, right? So regardless of the actions taken on the endpoint, the threat actor's network traffic is still visible, right? That's huge for us as well, right? Again, remember we're capturing out of band. They can't do anti-forensics trying to take us out there. But the biggest point for me is that I'm routinely asked as an analyst after an incident, right, or during an incident, asked, what did the threat actor view? What did they take? What did they? And sometimes I have logging available for that, and sometimes I don't, right? Unfortunately, very often I don't. Packet capture is a phenomenal tool for being able to help with this. There's tons of other use cases for it. I've covered a lot of different use cases for packet capture analysis in previous webcasts with Endace, but I did want to highlight this here. Increasingly, I'm being asked for good regulatory reasons, right? You've probably bumped up with GDPR and CCPA, right? DFS 500, unit PCI, the good old standby, right? Increasingly, again, notification requirements rely on what did the threat actor have unauthorized access to. It's one thing to say they had unauthorized access to this system, but did they view the records? Did they exfiltrate the records, right? What can we say about that? And I've worked multiple cases, and I could spend literally hours on this webcast. Well, I can't because we only have the remainder of an hour, but I could spend hours on this webcast talking about war stories where PCAP literally, pulled victory out of the jaws of defeat, right? One case, and I can't get into specifics here, but we were talking about notifying, a PHI breach where the notification would have gone to, somewhere in the neighborhood of 200,000 people, 200,000 patients, right? That would have had to have been notified. And because we have packet capture, that number was 30, right? That is a stark contrast. In fact, I can hardly think of many more stark contrasts. And by the way, at the time, that was not a reportable number. It was 50 or above, right? It didn't have to be reported to, less than 50 didn't have to be reported to HHS and the Office of Civil Rights, Health and Human Services Office of Civil Rights. And so they're the folks that deal with HIPAA and high tech. And that was just huge, monumental, right? Packet capture saved the day. Unfortunately, right, packet capture is not one of those things that we get to deploy after the fact. It's not like taking a disk image where the threat actor left behind what they left behind. Now I get a disk image. It's like, granted, EDR could be there and it could be giving lots of data, but packet capture has to actually be in play first, because once it's gone, it's gone. I don't have any historical artifacts like I get through a disk image. There's no backup for this. I either have it or I don't, right? And that's true for all network collection, right? So this is a spot where one of the reasons we like to highlight the value proposition of packet capture, is that, again, you either turn it on before the event and you plan for the event, or you don't, right? And if you don't, it's one of those wah, 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 sad trombone kind of moments, right? Okay. So we talked about the importance of packet capture. What about operationalizing it? Look, every day I get new indicators of compromise coming in through threat intelligence feeds. How am I going to operationalize these on packet capture systems? My friends, this is a big, big, big deal. You need to know what fields you can really search against, right? And by the way, I know a lot of user interfaces are like, you can search against any field you want. Okay, right? I can also hammer a nail with a snow shovel. That doesn't make it a good idea, right? So clearly I'm going to get better performance using a hammer rather than something else that maybe can also hammer a nail, right? So don't want to get into that, right? Okay, so hammer, nail, all that good stuff, right? So coming back to this, right, I want to know what fields are indexed, because if I know what fields are indexed, I know what I can search efficiently around, right? So this really helps me vector in with my indicators of compromise. My ideal situation here, right, is to filter either on a time range, basically slice out a time range and analyze all traffic, or at least all traffic that could be potentially of interest inside of the time range, or search against specific index fields, right? Now, that's typically what we do here. And in fact, all the stuff we'll look at today is really more exported for some granular analysis, right? Time ranges, again, can help us as well, but know which fields you have indexed, what you can actually filter against. Now, I want to highlight the Endace UI. And in fact, the Endace folks a few weeks ago here, did a SANS webcast with me as well, where we were covering the white paper that wrote about the product and how, we have multiple use cases. By the way, way more than I have time to get into here, but some fairly innovative use cases for packet capture in ways that you may not have thought about before. I highly recommend that you go take a look at that white paper and webcast as well. But they covered a lot more about the user interface than I will here. That said, I really do like the Endace user interface because it allows me to get into my bulk packet capture, and it allows me to go and start to see really high level statistics, right? What do I see overall in the traffic? Where do I see certain endpoints communicating with other endpoints? And then once I've identified traffic of interest, now you'll notice here, this is not Wireshark, right? If you're looking at this and you're like, that's not, Wireshark has way more features. Well, no joke, it does. But have you ever tried to load gigabytes of data into Wireshark? If you have, you already know how this plays out, right? One, Wireshark typically crashes on ingest because it's trying to parse everything. The second thing that we see happen is that, if you've got even, let's say, just a gigabyte file, right? You load that into Wireshark and you're like, filter, and you go apply that filter. It is time to go refresh your coffee cup, call your mom. She loves you, she misses you, right? All that stuff, because you definitely are not going to have that return quickly. That's just not going to happen, right? So it's going to be a fairly longer wait if you have very large files. What this allows you to do is very quickly triage areas of interest and then do deep dive analysis from a packet capture standpoint. And they allow you to do this, and this is one of my favorite features of basically of the Endace probe or the Endace UI, is that they actually have Wireshark built in to the probe itself, right? So what you effectively can do is you can say, okay, cool, I've got this data, right? I've got this data of interest. Now, typically in other systems that I've used, I've got data of interest, but man, I've got to tell you, I've got a tool that I know how to use. I use it well. It's Wireshark, right? I use Wireshark all the time for network analysis. And I got to tell you, anytime that I'm using something that's not Wireshark, right? Now, granted, I've got some other command line fun with T-Shark and, ngrep and you name it, right? But let's be real. When it comes to deep dive analysis, I'm going to be in Wireshark. And frequently what I found with other packet capture repositories and packet capture tools is that I'm able to vector in on data of interest. And now I'm downloading that data. I'm like, okay, now let me download this, right? Now, if I'm at a remote location where I have horrible internet, or if the probe is at, the packet capture probe is at a remote location that doesn't have great internet, and I say great internet, meaning internet that was just waiting for me to come and drag multiple gigabytes potentially back across the wire, that can be an onerous task. And then I may download this thing only to find it doesn't have anything that I want, right? It's like, nope, that one's not interesting. Okay, rinse, lather, repeat. And these can be multi-hour operations in the worst case. Even in the best case, we're looking at, multi-minute operations. Hold 1 second, my dog's barking. I'm gonna go close the door here. There you go. Hopefully we hear less dog and more. Let's see, will I come back into focus? Yes, there we are. Okay, and so again, as I look at the the integrated Wireshark here, this lets me do a preview on the box. I cannot overstate how important this is, how foundationally huge this is, that I can go and do network analysis. And again, all this happens through a web interface, right? They also now have Zeek built in to the probe as well, so that if I have packet capture that I then want to run through Zeek, bam, done, right? And so I don't have to download it. I don't have to post-process it elsewhere. It just happens basically on the probe. I just say, hey, go shift this, go launch this in Wireshark, go open this in Zeek. And now I'm not waiting to download. And again, if you've done work, by the way, if you haven't done, let me start here and say, if you haven't done work on some of these horribly bad bandwidth connections, right? Where you have a remote office, right? Where they, they're sitting out in a, like I've worked one recently with a dairy farm, right? Where they had, for the entire dairy farm, the best they could get was like this 256K DSL, right? That's huge. I mean, like I look at my ability to do anything dragging back across, that's, well, here, if I've got this ability, I don't have to drag anything back across to do analysis. I can verify for sure that the traffic of interest is there before I'm committing to that time. So again, huge impacts here. Wanted to sell, I say sell a little bit, but give Endace their due because again, they're sponsoring this thing. They're bringing this content to the SANS community. So all that said, awesome product. I highly recommend you check it out. I don't, endorse stuff regularly. I say endorse stuff, but like, don't always jump in and be like, yeah, these guys are awesome. I actually have one of these probes that they sent me a probe to play with and check out and actually test drive and all that. And I've been impressed, right? I'm a believer. Okay, so all that said, let's start with a quick overview of DNS, right? Typically, DNS typically resolves host names to IP address and vice versa, as it turns out, right? So there's something called a PTR record that we'll talk about here in a minute. But a PTR does basically the IP address and does a host name lookup versus starting from a host name and getting to an IP address. Right? DNS typically is UDP port 53. Zone transfers, on the other hand, work over TCP, right? So TCP for zone transfers. Now, you typically are not going to see a lot of zone transfers unless you have east-west packet capture, because you probably aren't doing zone transfers over the internet. If you are, stop it, right? Unencrypted over the internet, stop it. But typically when we have packet capture, it's not that I don't want east-west, I just don't always get it, right? I'm much more likely to get good north-south traffic than I am to get solid east-west traffic, but hey, whatever. So I will mention here that both the queries and the responses are interesting in investigations, and they're interesting for different reasons, right? So this is a great reference slide. I would say if you take nothing else away from this, right, this is probably a great place to have just a good chunk of record here, where you can kind of go back and take a look. And we'll actually look at a few of these different types today. I want to show you a couple of things that I've seen threat hunters and folks that don't do a lot of this analysis get a little confused about, right? So, but the most common record that we're going to see is the A record. Probably followed by the CNAME record, honestly, right? So an A record is just an address record. It basically is, hey, I did a request. I wanted to know, what is www.malwarejake.com, right? Okay, I get an A record back for that. Now, if I also had IPv6, I might get a quad A record back for that as well. You probably know, excuse me, goodness, you probably know that a IPv4 address is 4 bytes. And a IPv6 address, well, what are the odds? 16 bytes, right? And so basically you're looking at quad A, 4 times the size, 4 times the size of the A record, right? So quad A's, right? Although I would have thought it'd been super cool if they gone like 6 A's for IPv6, whatever. Anyway, I didn't write the standard, there it is. CNAME's an alias, right? So sometimes we'll see aliases where, maybe you've got a www3, right? Dot malwarejake.com, right? And maybe that's my staging server. So I might have a CNAME, right? That the actual A record is www3 because that's the name of the server itself. But I might also want to have an alias for it. So I can substitute out where it's pointing to, and maybe I call it staging.malwarejake.com. And that's a CNAME record, right? It's an alias record. And then we get into other records like, what are the name servers? What are the mail exchangers, right? What are pointers? The pointer being a reverse mapping an IP to host name. SRV records, our Active Directory folks made these popular or made these famous, I guess. But SRV records, and then your AD really made these famous because they have basically pointers to different services. And give me 1 second here. I want to. I've got a dog howling here. Let me go throw this dog. I'm just going to text somebody and ask them to throw the dog outside. Let's throw. is howling. I don't know if you can hear the howling dog in the background, but he's actually howling.
I can't hear it, Jake.
No, you can't hear it. Rock on. Okay, fantastic. He's literally howling above me. So my apologies there. Okay, that makes me feel so much better. So that text record here is machine readable data communicated over DNS, right? So these are really important records, and we'll take a look at these because they do something special that we typically see with text records that we don't see with other records. And that's that they often use TCP to actually do the resolution. Text records, as it turns out, are much, much larger, or can be much larger for the returns. If you tuned into the email or the SMTP and IMAP, very specifically the SMTP, we briefly mentioned SPF, right? So Sender Policy Framework. And SPF basically designates authorized mail servers that can send on behalf of a domain. And the SPF record, if I've never talked to, let's say, malwarejake.com, or actually, you know what? I don't know why I'm doing that, endace.com. If I've never talked to endace.com before, how do I know, or they've never sent me an email before, how do I know which server should be able to send on their behalf? And the answer is SPF. And so what you do then is you basically create an SPF record, right? And that SPF record then basically shows the servers that are available that should be able to communicate. Well, obviously that could be a large record. And that's why those text records then are ultimately transferred very often over TCP. Right? So likewise, finally, we have starter authority records, SOAs. These are what are the authoritative servers for the domain. And then there's a lot of other information, points of contact, who's the admin, and then a serial number, right? So basically a serial number saying for a given zone, this helps primary and secondary servers, for a primary servers and any secondaries, basically know, who has the most up-to-date copy. Do I need to pull a new copy per zone transfer? And if the primary has been updated, right, it'll have a newer serial number than what's there on the secondary servers. Okay? So I'm going to deep dive into this in a minute as we get into more of the analysis, but I would be remiss not to talk about DNS over HTTPS. This is the devil when it comes to DNS monitoring. It's the devil, right? So some of our browsers now support DNS requests over HTTPS. This is definitely a thing that we are going to see more of. There are a lot of opinions around DNS over HTTPS and DNS over TLS, which I'll talk about in a minute. I'm not here to tell you it's good, bad, or indifferent. In the US, most people are not that worried about their privacy from an ISP perspective. I generally, when I hook up to my ISP, I don't think, hey, the ISP is probably here to compromise me. They're going to steal my data. I don't think about that, right? Because it's not something that happens. I'm not saying ISPs don't compromise your data. Please don't think that, right? I'm not saying they do either. But it's a very US-centric view. I've done a lot of work over in Southeast Asia, done some work in Africa as well. I bring these up as places where very much people worry about ISPs, right? And so, having the ability to hide your DNS traffic, a very valuable source of traffic from your ISPs, that's a big deal. I will also mention that even the US and the EU, right, and certainly in Australia, New Zealand, and all that, we had ISPs as the DNS over HTTPS standard was being discussed. We had lots of ISPs lobbying against it, right? And why would they be lobbying against it if they weren't doing something valuable with that data, right, that they now can't see? They lobbied very heavily against it. With some of them were like, for troubleshooting. Now look, in enterprise, I'll be the first to tell you, you should disable this, right? You want this visibility inside your enterprise, right? That's just a reality. The value of any privacy once that data leaves it. And by the way, too, you can set up a resolver that then sends DNS over TLS. So inside, you're still getting, the good stuff unencrypted, but then as it goes out, it's sending it over TLS, that way, right? So anything on the internet then is blocked, encrypted effectively. So this is a big deal for us. Again, I bring it up here because I'd be remiss not to. Your browsers are using it by default now. Most of your web browsers are using it by default. And so if you're doing this again, you're like, hey, why am I not seeing this? You can go in and actually modify your browsers. It used to be a group policy or enterprise policy for Firefox and Chrome, or enterprise administration policies. And so you can go disable DNS over HTTPS so that you see the original good stuff. But I do want to highlight here, what does this look like in packet capture, right? And we'll take a look at this as we deep dive, but I want to cover a couple of slides here before I do that. First off, for obvious reasons, right? The IP addresses of your DNS over HTTPS providers, right? They're not hard coded. And so you'll know you're using DNS over HTTPS, right? When you see, for instance, this, right? We see a plain text DNS request to mozilla.cloudflare-dns.com. You are one Google search away from finding out that that is one of the largest DNS over HTTPS providers, period, right? So one, if not the largest one of, right? So yes, basically here then, again, I'll mention here, you can tell the IP address here just by looking at the response. Well, now I've got this to filter against. Get out, come on. Sorry, man, I'm messing, this dog thing is out of control today. I texted my partner here to remove the dogs and somehow another one came downstairs. So my apologies. Okay, so as you have the IP address now, I can filter against that. And you can see this looks just like HTTPS because it is, right? Now, my problem is I can't see any of this traffic, right? I don't have Cloudflare's private keys for what should be obvious reasons. I don't have Cloudflare's private keys. I can't see it, right? So I don't know what requests came after this, but I do know that this is DNS over HTTPS traffic because, again, I know the IP address that was just used here. I know what the IP address specifically is. And I know that the, basically here that was returned for that Cloudflare DNS. And again, we lose complete visibility on this. I don't want to lose visibility on this. I want to know where my users are going. I want to know what's being requested, right? And Cloudflare clearly has that data, right? I need that data for my own enterprise protection as well. So you should, in the vast majority of cases in your enterprise, turn off or disable DNS over HTTPS. I will caveat that with lots of work from home users, right? This is now something where you really have to step back and say, do I want to, do I want to support that, or not? If my users on-prem, I definitely want DNS over HTTPS disabled. If my user is off-prem, there's a little bit of a privacy advantage there for having DNS over HTTPS. So if I can't move those, multiple profiles, depending on where they're sitting, on-prem versus off, this is a choice that I end up having to make. The way I verbalize this, though, to my security leadership is that, look, for years, most of our internet existence, we didn't have this feature and everything was okay, right? And again, my risk calculus is different sitting in the US than it is in Southeast Asia, right? And that's not targeting anybody. It's just I've been there and I've seen ISP compromises directly there. Basically bad actors at an ISP using that to target end users. And I haven't directly seen that in the US. And so I'm kind of like in the EU and Australia and New Zealand. And so I'm kind of like, maybe some parts of the EU as you move like super east or something sounds a little more sketch, but whatever. Anyway, so again, I'm starting with this IP address. Grab my highlighter. Start with this IP address, boom, and then, right, now I can filter against the IP address. Perfect. Very quickly, before I dive into the actual packet capture analysis itself, let's talk about DNS over TLS. I'd be remiss not to also mention this. DNS over TLS operates by encrypting DNS requests over TLS as a transport layer protocol. People have tons of confusion about this. By the way, too, this may be the biggest thing you walk out of the webcast with today, right? Is understanding the delta between these two. I'm bumping into CISOs that are like, no, DNS over TLS is better. I'm like, there's no better, right? That's like asking which car is best, right? For what, right? If I want to transport furniture, I need a truck. If I want to, win a race, a Ferrari is a much better vehicle, right? If I'm a soccer mom, I probably want like a minivan, right? So again, best for what use case, right? So DNS over TLS is using TLS as a transport layer protocol, not embedding something in HTTPS, which is then with the HTTP overhead, by the way, which is then, yes, using TLS as a transport layer protocol for encryption. There's additional overhead with DNS over HTTPS. So as far as best goes, it's best for the situation. Both of these offer the same encryption protection, right? You're not seeing into either of them as a threat actor. As an eavesdropper is not seeing either of these either. DOT and DOH offer the same protection. It depends entirely on the application. The reason DNS over HTTPS, DOH, got so much traction initially and so much attention initially is that it was largely put together by browser vendors, right? So browser vendors largely, kind of led the charge on this, right? So basically they don't have direct access, right, to go lower layer and create another, or say create, but use another transport layer, but they're already doing HTTP, right? So they obviously gravitated to that. Now, if you're an operating system, vendor, you don't want to have to add the HTTP, layer, right, in order to do a DNS request. That's just ridiculous. And so now we have DNS over TLS, right? And so if you're an OS vendor, it makes much more sense to do DOT. If you are already doing web browser support and you're already supporting HTTPS, it's an obvious extension to do it. And in fact, going lower, in the stack there creates new problems for you to deal with, right? So anyway, wanted to call that out there. Foundationally, no big difference. It's just about whether or not we're going over HTTPS or just making a direct TLS connection. DOH, I think, is going to serve browser vendors very well. Windows they originally did DOT exclusively initially, and then they backported. They're like, well, we'll also support DOH, largely because they need to go find other servicers on the internet. Unsurprisingly, there were more, servicers or DNS resolvers that adopted the DOH standard initially. Okay, that was a lot. Bam, to the PCAP, right? So by the way, these slides are available, will be available, are available, etc. So let's do this. There we go. And I guess I'll start with, let's see, what do we have available here? And I'll start with here. First off, I'm going to start with a Wireshark of the, let's do the Facebook NS lookup. Make this a little bit bigger here. Okay, so I'm going to start with here, first off, is just basically this was me just doing a simple DNS lookup. I did an NS lookup in the command line and said, hey, go find me www.facebook.com. I want to deep dive into this in Wireshark a little bit, just look at a couple of the protocol fields here. I don't know why I dragged that up. It's perfect where it's at. So basically, a couple of things I want to note here. First off, we're starting with a transaction ID, right? So this transaction ID effectively is almost the equivalent of, let's say almost the equivalent of, scratch that, analogous to a TCP sequence number. And so when I see the response, it's going to have the same number, should have the basically the same transaction number. In fact, I'm going to go ahead and filter against this. I'm going to say, hey, go apply as filter selected. And sure enough, you see that referred to as, notice here, Wireshark even picked it up and said it's the DNS ID, right? So the transaction ID. And notice here, we've got a query response, right? Now in this packet capture, this is super easy for us to go tie these back together because there's only like 6 packets, right? So no big deal there. But when you've got these giant packet captures, seeing stuff interleaved, you're like, there's the query, where's the response, right? Yeah, very difficult to do. I say very difficult to do, but a little bit of a pain to go and track down. So this is your secret decoder ring, is to highlight the transaction ID. By the way, here, notice, even though there are 2 requests and 2 responses, what we end up with here effectively is that basically what we end up with here is this only covers, basically the request and ties that request uniquely, basically uniquely to that response. Now, one of the things that I normally will do a lot of work with here, let me see if where's my other packet? Let's see, that's not big enough there. Let's see, what's a big one here? Oh, there we go. The Wireshark and this guy. And one of my other go-to kind of tricks here, there we go, success, right? So I'll say frame contains success, right? So what you'll see frequently, and by the way, if you don't know this cheat code, this is phenomenal, right? So the frame contains, use the tar out of that, right? Because man, does it work. By the way, just to clarify here, I want to make sure you can see my Wireshark, right? I'm not just talking here. Somebody confirm, Mark, Carol? Any of the above? Oh no.
Yes.
Okay, good to go. Okay, I was worried for a second. I'm like, oh no. Okay. Also, I see a Q&A pop up here. Oh, I see a yes. Kevin, awesome, man. Thank you. Okay, so great. So frame contains, I absolutely use this trick all the time, right? In fact, I could even go and say success.txt, right? This is like packet grep, if you will. Now, there's a bunch of issues with this because because of fragmentation or, continue, like part of that text could be in one packet, one payload, part of it be another. There's all kinds of potential issues, but use it for what it's worth. It's awesome, right? So I want to show you that works here. Now, when I come back to Wireshark and I'm like, oh yeah, here's my Facebook lookup, I might say, right, frame contains facebook.com, right? The problem is here, notice you don't get anything back, right? And so I'm going to drop back out of this here, right? And I'm going to go apply that filter. Now you can very clearly see facebook.com. What gives? Why does this not work? Well, I want to come back up here then a little bit and take a look at this query. And so our actual, as we decode the field here, right? You'll notice here again, facebook.com. And so notice here, we see a 03 followed by 777777, right? So basically it says the first piece of the request is going to be 3 bytes, www, right? So hex 77, hex 77. In fact, if you didn't know that, you can just drop into Python, right? And you could say character CHR 0x77, right? And you can see that's a W, right? I'm not going to do all of these because it's going to get really boring really quick, but that's converting just a quick ASCII lookup, the hex character. So you see 03. So that means we have 3 characters, count 1, 2, 3, and then 8 characters. Facebook, right? And then 03, 3 more characters, COM, and then 00, a null byte that says nothing else comes next, right? So we can start and basically skip ahead, right? So 3 bytes, 8 bytes, 3 bytes, nothing, right? Okay, cool. That's why frame contains doesn't work. If I say frame contains Facebook, game on, we've got it, right? But if I add .com, no go. Why? Because there is no .com. What you can do here is you could say end frame contains. That works because each of those are there. Bring the 2 together, they're still there, right? It's still there on the same, basically the same page there. So all that said, right? Okay, set, good to go. I just wanted to highlight this because this is something that confuses the tar out of people. I can't tell you how often I'm working with junior analysts doing packet capture analysis, and they know the frame contains trick. They're like, okay, I'm going to go search through all of it, and you're like, no, it's not going to work that way, right? So again, it's just know this about DNS, that it's parsing. Plus, this is a neat party trick if you go to the right parties, right? So 3, 8, 3 kind of thing, you go like that. Anyway, okay. So the other thing I want to highlight here is note that we did get a couple of responses here, right? So we've got an A record, right? And that's the, we've got an A record. And by the way, too, on the answers, let's actually take a look at the answers here, right? So I asked about www.facebook.com, but it returned me a CNAME record, and it said that's an alias for star-mini.cr10.facebook.com, or sorry, C10R, C10R.facebook.com. And then, right, because the Facebook DNS server knows it's coming next, right? It's like, yeah, if I return you an alias, you ask me for www.facebook.com, and I'm like, hey, no, if there's an alias fact, you're like the worst friend ever, right? So you generally then want to respond with additional data because you know what's coming next, right? You know they're going to make a request for that. So they'll add basically another record there. If you're thinking this is ripe for attacks, you are correct. As it turns out, the late Dan Kaminsky, man, what a loss. But the late Dan, great guy too, by the way, but did a lot of work on DNS, and basically he caused folks to rewrite the book on DNS security. One of the things that he discovered early on was something called, that's referred to as the bailiwick attack, where a threat actor who was doing some DNS spoofing or could convince you to communicate with a DNS server that was under your control, maybe I would send you a link to like www.evil.com, right? And you would click on that link or see that link and make that request. And then what was going to happen was immediately then it was going to come back and be like, bam, here you go. It's not only the evil.com, you probably want to know about bankofamerica.com and a bunch of other and it would poison your DNS cache effectively, right? Well, Dan, highlighted this attack early on. He highlighted lots of other really more complex attacks, but early on that was part of his research, and that led to standards with resolvers now saying, you know what? If I ask for facebook.com, that's fine. You can offer me other facebook.coms. I ask for www, right, .facebook.com. I'll take other facebook.coms as a returned record. So like star mini CR10, that meets the bailiwick test, meaning the end of the domain, right, is basically the same, right? It's a facebook.com domain. But you could send other records for a google.com, but they're going to be ignored, right? They're going to be dropped, right? So effectively here, Facebook is jamming an extra record in. This is okay for security. I already know some of my security-minded folks are like, wait. This can't be real. Yeah, it is. It's a convenience thing, right? So wanted to highlight here again that we see both the CNAME and in old resolvers, right? Old resolvers would not anticipate that you were going to make that host request, but we all know that's coming, right? I mean, it's obviously coming. So they don't make you make the extra request. From a performance standpoint. It's better just to send that back. The other thing I want to show here as well is that they also return a quad A record. Right, so separate quad A record. The reason, by the way, that this is in a separate return or separate packet, separate response. Excuse me. The reason this ends up being in a basically a separate response here, or sorry, separate. I said separate responses. It makes a separate query, but also, again, it's I'm looking for IPv4 or IPv6. Obviously, the size of the return has to be substantively different, right? Notice here the address, again, 16 bytes. Whereas again, if I come back here before and I'm looking at the response here, looking at the address, come on, right? And so you can see here the 4 bytes of the actual address. I need a foundationally different sized record to return that. But I want to show you this because it's pretty cool. If we take a look at the actual address, notice here the IPv6 range for Facebook, right? Facebook. Right, or V00C. I just think that's cute, right? So if you go look at queries for Facebook, you will inevitably see that, right? So because Facebook's IPv6 range, they pretty standardly use, in addition to the prefixes, right? They pretty standardly, put Facebook in the response, which I don't know. I think it's pretty cool. Okay, so anyway, enough about that, right? I want to take a look here at the. Here we go. Let's see. Myself, let's take a look at SANS. Okay, let's do the SANS, right? So Wireshark, SANS, SPF. How many SANS? Oh, I have a SANS demo as well. Yeah. In my packet capture, if I see a source as natted IP, how do I figure out the original host that sent the IP request? It's a fantastic question. This is, and the IP request, we're going to say a DNS request. How do you know the original endpoint that sent it? You don't. That's a problem with where is your sensor placed, because you're looking at, for those that don't follow the NAT piece, NAT is network address translation. And so all you're seeing is the post translation. You can't see what's behind the NAT gateway. That's actually by design. So I say that, and then I'm going to tell you a couple of tricks here, right? So one of the big things that I'm, that I'm looking at, if I've got coverage on both sides of the NAT gateway, very often that transaction ID doesn't change, right? The DNS, a lot of your NAT gateways, I'm going to mention, operate as their own DNS servers, in which case all bets are off, right? But if it's just purely a network address translation, that query, because that's at the DNS, request there ultimately sits up at a higher layer, that doesn't change. So I can marry those back up. And I've had to do that in a couple of cases before to basically break through and be like, okay, but who inside made a particular, not a request for a specific, basically a specific domain, right? But this specific request at this time, ... and I've got clock skew, and that DNS query ID is a 2-byte field, but that's pretty unique. I mean, for it to roll over, it's a 1 in 65, or well, 1 in 64K chance, 65536, 1 in 65536 chance that we're going to have, a collision there, right? So I wish I had a better answer for you, like an easy answer. But a lot of this comes down to sensor placement. And that's the kind of thing that Mark and his team do a lot of work with over at the Endace crew. Mark, do you have any thoughts around that you want to chime in on around sensor placement and that?
No, except that typically we do see people tap on both sides. So yeah, and obviously you can do that with the same probe, actually tap on multiple locations from the same probe.
Yeah, that's actually something I didn't mention before because I wasn't like deep diving into the probe specifically, but I do love that, right? Where you have the, basically you can add as many interfaces you have space for there with the little SPF connectors there, which is, again, just fantastic. So, but yeah, so you can use the same probe and tap on both sides of the NAT gateway as necessary. Yep. So, okay, so I did the SANS lookup here and did a couple of things, right? So first off, I made a request for the mail exchanger. I said, hey, I want to know who is basically what is the mail server there specifically. And the way I'm doing this here is I'm doing a dig and I'm saying I want to know type of MX record, right? And so this is going to be who is the email server for SANS, right? And so basically I've got that request, and of course I can go look at the response, and that's neat. But then I said, you know what? I need to know more data than this, right? And I could have done a specific lookup for the SPF record, but I was lazy. Also, I was lazy for a reason, because I wanted to show you something else, right? And that's that when I did the dig minus T, and by the way, in case you want to see this in action, literally it's not a git, dig minus T text sans.org. And so when I do this, right, I'm up arrow there, so you've got the command there. When I do this and I run that dig command, I'm getting all of the text records back that their DNS server knows about. Now, of course, one of those, as it turns out, is this SPF record. But you can see it's a lot of data, right? And by the way, none of this is sensitive, right? There's site verification token. What are you going to do with that? Google already knows who SANS is. And likewise, if you go do this on your domain, you'll find that you probably have lots of these as well, right? I use SANS here because sometimes people think this data is sensitive, and I want to make sure everyone knows, like, it's not. It's so not that we're just like, it's out on the internet. You can just see it, right? But all that said, now I know, right? In case, now this is actually interesting from a security standpoint. Of course, you can look here and be like, oh, that's Valley Email, right? Well, if you know Valley Mail, they are they do like email protection-y stuff, right? And so got an idea there, right? And I can say, okay, I've got, yep. I've got the 205.220, so actual IP addresses of servers that should be able to send mail on behalf of SANS as well. So I've got that data there. But again, I didn't do this to look at the SPF record. We talked about SPF a little bit in the email analysis webinar. What I wanted to do instead is show you that ultimately here I made a request, right? And I said, hey, tell me about the text records that you have, right? And it said, okay, sure, right? And then I get a response, right? So, okay, got a response coming here, right? And so said, okay, so we've got the response here, and it says, okay, look, right? So we should expect at this point now, based on the response, is okay, this is too long, effectively. And so what it's going to do now is it's going to say, okay, instead, go back and reconnect over TCP, right? It's saying from the option side, go back, reconnect over TCP to go get that data. And you probably followed a TCP stream before. You've probably seen this done. And that's exactly what's happening here, right? So effectively here, now we're seeing all the same data, albeit not as pretty here, right? There's no line breaks, as I'm sure you can imagine. There'd be no reason for the line breaks like we see on my, because ultimately here on the console, this is all formatted, right? But the actual raw data, right? This is our raw data, right? This is the data that we got back for these, basically for these text records. So I wanted to highlight that for you as well. I have people freak out about this, right? Because in a lot of older material that are the extended DNS effect, eDNS. So before we had the longer DNS responses, in the days of old, I believe the longest DNS response in the original RFC was 512 bytes, which conveniently always fits a new UDP datagram, ... right? And then you get into these big text records, they can be arbitrarily freaking large, right? And you can send whole, novels over DNS. And so as a result, what you end up seeing then is a lot of TCP connections being made. Unfortunately, a lot of old material basically old material says DNS is always over UDP unless it's a zone transfer, in which case it's TCP. So I have a lot of analysts then that see something like this where text records are being queried. They see a TCP connection on port 53 and they're like, oh my gosh, it's a zone transfer. And it's not. I mean, it could be, but this is not, right? Now I've got a question in here where somebody asked, do you see DNS embedded in Quick? And for those that aren't familiar with Quick, this is QUIC. And the short answer is, I haven't yet, but I'm sure it's coming, right? I'm sure it's coming. I think we haven't seen it specifically because of the HTTPS, DNS over HTTPS model. I have no doubt that Cloudflare is heavily invested. Cloudflare is one of the big backers behind DNS over HTTPS and the whole standard with it. They are very interested in Quick. For those that aren't familiar with, not familiar with Quick, Quick is a basically a multiplexed fast, fast data transfer. It uses UDP, but it's more reliable the way TCP would be, right? So, or can be reliable the way TCP would be. Basically saying, hey, we're implementing a higher level, error checking. We don't need to do a three-way handshake to make a request, right? So this is something that you're going to see Quick, by the way, since we're talking packet capture anyway, is something you will see a lot more of, very specifically because of your friends at Microsoft. Microsoft in Windows 11 for basically for file services, file sharing services, they now have basically SMB over Quick, right? And so with SMB over Quick, by the way, Quick is automatically encrypted. That's another thing on the piece there. It's always TLS encrypted. There's no three-way handshake. And again, at a higher level, all the error correction and sequencing is done, right? So UDP, though, is the transport. I guess technically it's its own transport layer. Uses UDP for transport layer. So anyway, I haven't seen it yet. I'm not saying it doesn't exist, by the way. This is a fantastic question, right? I'm not saying DNS over Quick doesn't exist. I think it probably will down the road. I just don't know, know when. But Cloudflare, again, has a huge investment in DNS over HTTPS, and they also have a lot to gain by making it more efficient via Quick. I think it'll come, just a matter of when. Right? Fantastic question, man. I could deep dive on that. I feel like I could deep dive on that for a while, but I'm not going to because we have more to cover. And obviously, as usual, I'm not going to get to all the PCAPs, but one I do want to show you, right? And this is one that I got. I want to cat the readme.txt. Right? And I want you to note here this DNS cap.pcap that we're going to look at here. This actually came from B-Side San Francisco. And this is a challenge that they had there. It did some DNS exfiltration. I like this. It's a fun one to play with. And so I'm going to go draw, not frame contains Facebook. Let's see, there we go. Let's jump into this one, right? So a couple of things here too I want to highlight. I would mention here that very often when I go into a packet capture that I don't know what's in the PCAP itself, I'm a big fan of the statistics, right? And by the way, this is a fantastic thing to do on the probe, right? You have full Wireshark support. So you've got a good, good idea then of kind of what's in the packet. I love to take, the packet capture. I love to take a look at protocol hierarchy. This is built for CTF. It's already been pre-filtered, right? And so it's only DNS, right? But if I go back to one of our other, let's see, SPF, what is, apparently I have a bunch of SANS SPF opens. Okay, if I go back to another one though, just to highlight something a little bit more, let's see, Wireshark. Let's see, here we go, that doesn't work. Okay, and I do a statistics and a protocol hierarchy. You can see now kind of what's in the packet capture overall. And likewise, there's a bunch more that you can do with statistics that is awesome, right? But here, all I'm interested in here is seeing kind of just a high level overview of what's in the packet capture. Now, again, for that DNS cap.pcap, again, it's all DNS all the time, but I can see that very quickly here. Now, real quick too here, I can look and I can see I got SkullSec Labs, SkullSec Labs, SkullSec Labs. This is a lot of packets. In fact, if I come and look down here, it says 382 packets. I probably do not want to individually walk through all of these packets. And this is where we've been doing a lot of Wireshark stuff over the last several, get-togethers that we've done. This is a spot where I'm going to tell you I use T-Shark all the time for DNS, right? And so I'm going to show you here is this T-Shark command line, right? Now, there's a lot you can do with T-Shark, right? But this is going to really help me here to start to take a hard look at what are the payloads that are being ultimately generated here? Now, if you go back and you follow, if you're going back to my GitHub repo here and you're taking a look at these packet captures, there's a write-up where this guy does a bunch of work with Scapy and he does some other stuff. I'm like, yeah, okay, cool. I mean, again, I love Scapy. You should learn Scapy. It's great. It'll make you a better packet capture master if you have the packet capture in the first place, of course. But here again, maybe I want to just do a quick question of, when I say grep -v, skullseclabs.org, is this all going to skullsec labs, right? What's going on? grep -v removes that. Yes, everything here that's DNS, right? Because I said, show me, right? Anything that is a DNS query name, just extract that out to the command line for me, right? Maybe I've got a question of how many of these do I have in the first place? And by the way, this command, the actual T# command is in the slides. In fact, let me, oops. Let's see. Garbage. There we go. So this is in the slides. I did want to show you that here quickly, so you're not like, oh my gosh, what was the command? It's there in the slides. You can pick that back up as well. But here I've got 382 packets. 382 of them belong to skullsec labs. Maybe I want to come in and take a look and say, do a sort, right? And then I'm going to pipe that to unique -c. Now, inevitably, somebody tells me when I do this, like, Jake, sort -u. I know that does a sort with a unique field, but I want to know how prevalent are the different requests, right? And so then I'm going to do again, and I'm going to do a sort -n. And what this does then is it tells me how prevalent are these. I've got a bunch here with 2s. I'm just going to turn this around instead of scroll, and I'm going to do sort -rn, right? And now I know that my top number is 2, my bottom number is 1. That's our range, right? Okay, so these are all fairly, some of them are unique, some of them are not unique, but even the ones that aren't unique don't happen a lot, right? And so that's actually really useful for me as well. And then I might even look here and I might say, this looks a lot like, looks suspiciously, right? Like hex, right? And then maybe at that point I start doing some cutting, right? Here I get rid of this, right? But maybe I do some cutting, or I remove, the skullseclabs.org, like with a sed command, right? I don't have time to command line ninja a bunch of stuff here, but again, wanted to highlight this for you here just as a quick example of what you can do with T# in very specific. All the time people are like, yeah, and this is where T# is really cool compared to, it's really cool compared to Wireshark. And most often they're contrived examples. This is not a contrived example. If you are in a position where, and by the way, you can go home and use this today, if you've got a bunch of packet capture that is DNS in your enterprise, and you want to know how common are specific domains, right? Or even TLDs, you can do some great work with this, right? Where again, you're just looking for sort, pipe unique, right? And then sort -n, or sorry, unique -c, right? Because that gives you the count, right? And then you just do the sort -n. And again, now I've got a list of what are the different domains that are being, that are being pulled in. This again is fantastic. And there's so much more command line ninjing I could show you how to do, command line ninja work, right? That I could show you how to do here with a lot more time. But again, I wanted to highlight this here because this becomes a really, really useful tool. T# does, specifically with DNS. And I find myself grabbing those, basically the query name, more often than anything else. As we wrap up here, I'd be remiss not to mention that, of course, Zeek. I'd be remiss to mention, of course, that that Zeek also can do that query, basically pulling out fields for you. At which point you can use the brocut command. It's still brocut, even though it's the Zeek. But you use the brocut command to just cut out that one field, the query name field, out of the DNS logs. That are generated by Zeek itself running across a packet capture, which of course you have access to in the Endace probe itself, right? And folks, unfortunately, it brings me right to the top of the hour. And I could keep talking about DNS, fortunately, keep talking about DNS for a long time. I'm unfortunately out of time though. So I do want to close out here and note that if you have DNS over HTTPS or TLS in your environment, really disable it, right? You want that visibility so you can do some of the stuff we did today. That packet capture you're looking at there is definitely data exfiltration, right? There's actually a PNG inside the whole PNG that got exfiltrated via those basically hex codes that you see there. Again, the walkthrough is there for the README. DNS is a huge source for investigation. So I'm going to wrap it up here and just once more thank Mark and the team over at Endace for sponsoring this and bringing this to the SANS community. I hope you've learned something that you can take back to your organizations. And I hope overall this whole series that we put together, we're already talking about doing more for next year. I hope that this has made you more comfortable in Wireshark doing network analysis. Carol, I'm going to turn it back over to you to close out this webcast. Thank you so much again for the Endace team.
All right, thank you so much, Jake, for your great presentation, and to Endace for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.